Beth, I don't know if you're going to watch the video, but if you do, feel better. All right, so 11-2. Some of this is going to be a review. Some of this is going to be a little bit of an extension. So we're multiplying and factoring polynomials. Now, where this steps up to like harder stuff is tomorrow when we do binomials times binomials, which is where we get into the FOIL process. But right now we start with the, I don't want to say easier aspect of it, but an aspect that you should recognize. So let's get our brains in the right frame of mind. So we have this plot here. Grass seed costs 3 cents per square foot. Write an expression for the total cost of the seed. And then, suppose we buy $50 worth of seed. How wide could that section of grass be? Well, we know the area, well, no being relative. We know the area of the whole space. We know the area of the flowered portion. What we don't really know is the area of the grass portion. So how can we write an expression for just the grass area? And then we'll tweak that expression to show the cost of the seed. Later?
X minus 10 times 45.
Yeah, if we take the whole length x minus 10 and then multiply that by our 45, there's our length times our width. Now, that though still will have to be multiplied something to find cost, but we'll leave that for a second. So if I just have this x minus 10 times 45, what do I need to do with that? We always want to simplify things if possible. Straddler? What property are we going to use? The distributive. So we're going to distribute our multiplication. That's going to be 45x minus 450. Now, what else would I need to do with that to determine the cost of the seed? If that's the area, that's how many square feet we have. Jacob?
Wouldn't you have to multiply it by 0.03?
We would. Yeah, we would.
Yeah.
To get
like the cost.
0.03 per square foot. This is in square feet. Even though we don't know what it is, it was length times width. It's got to be square feet. So if we multiply this whole thing by 0.03, which really we should technically, to make it nicer, 0.03, then we're going to have to distribute that. Kind of drew that arrow weird.
That was really weird.
Yeah. What's 0.03 times 45? Ben?
1.35.
Karina Sanchez Queen to the office, please.
Nope, still not in this room. Oh, she must have not just paged this room. I heard them page a room. Sorry, what'd you get, Ben? 1.35. And then we know, since this is just 10 times, so then as soon as we know what the x value is, what the entire length of that yard or plot or whatever you want to call it, then we can find out what the real price is.
I know I was in this drawing step. Oh wait, never mind.
You don't think what?
It was very close, you know. I couldn't really tell.
Well, we don't know what x is, so we can't really tell.
Like, comparing the 10 feet to the 45 feet.
That's pretty close. This looks a lot like a square.
Yeah.
So if we say that this would just have to multiply by 4.5, it's probably pretty close.
That's pretty.
You're probably just missing a half, maybe.
Dion cannot see.
Well, that's not good. You can get your eyes checked.
In this problem, you will multiply a monomial and a trinomial.
Distributive property.
Which polynomial is a simpler form of negative x cubed times the quantity 9 times x to the fourth power minus 2 times x cubed plus 7?
You're used to like 3
Your
times
choices are
5x
4
minus
trinomials.
4 or something like that. Now we step up to where we have a variable term on the outside, and it's going to multiply in with our variable terms on the inside. This is where you have to use those rules for multiplying with exponents. So I really don't like the multiple choice. It just kind of gets in the way. So we look here at negative x cubed times 9x to the fourth minus 2x to the third plus 7. First thing we got to do, Jacob.
Okay, so you would distribute. So really, in front of the x cubed, there's a negative 1.
Yeah, so really there's a 1 out here. So we at least think about that, even if we don't draw it. Then what do we draw? You guys may like think this is childish, but I always draw these.
You would draw arrows.
The arrows showing the multiplication. Now I'm going to color code these. My first multiplication, negative 1 x cubed times 9 x to the 4th. My second multiplication, a negative 1 x cubed times negative 2 x to the 3rd, because the sign in front of the value has to go with the value. Oh crap, use the wrong color. Of course I would. Negative 1 x cubed times negative 2 x cubed. I always assume addition between them. So then negative x cubed times 7. Then we got to think about our rules. When we have a power times another power, what do we really do with the powers? Add them, right? So we multiply the coefficients. Negative 1 times 9 gives me negative 9. Then we add the power, so we get x to the 7. You guys should all be writing this down, by the way. Negative 1 times negative 2? Positive 2. So now we do have addition between x to the 3rd times x to the 3rd?
X to the 6th.
X to the 6th. And negative 1 times 7? Really, this is pretty easy. The 7 just becomes the coefficient. So we get a negative 7x cubed. And we could rewrite this just as subtraction if we wanted to. Make sense? Try the got it on your own. Be careful of signs and powers. That's where the most common mistakes come in. Dealing with the signs or the powers. Yes, I know, but I'm going to start using cards now. You've already kind of milked your multiple opportunities.
Good job, Jacob.
Hey, why are we hating on each other? We need more love. Where is the love?
Matt is love. Vita is life.
What?
You should know this.
Oh. Well, I wasn't thinking.
I think I might have gotten
It was,
Life,
yeah.
life.
Well, you say random things all the time, so what am I supposed to think?
Five n's going to distribute to all three of the terms there.
Jacob.
Now we fortunately have a positive value out in front. Olivia, your card is up. Do you think you have an answer for us? Possibly. What do you have? Okay. Ah, sorry. I either misheard you. Yeah, I probably misheard you. Yeah. I was waiting if somebody caught it, but you caught it yourself. Any discrepancies?
I actually got that right.
That is our correct answer there. Now, factoring.
Oh, I have it for Jacob.
What, Leon, is the trick with factoring an expression like
Okay.
this?
I usually look at my term with the smallest degree.
Yes. Always look for the smallest degree, and
Then you look for what multiple would go into all the others.
yeah, so there's a trick to do that though.
The one with
Factoring, pulling out the greatest common factor. So factors are two things that multiply to get your term. Jacob?
I would normally look at the one with the lowest amount.
Yeah, so here's what I'm getting at. You want to look at the lowest index or the lowest power, like Leon said, and then look at the lowest coefficient. Because the lowest power is going to tell you what power you can factor out, and the lowest number, coefficient, is going to tell you what actual coefficient you can use in your greatest common factor. So I'd like you guys to show the division on your paper. What's our common factor that we can pull out of all of these? 5x, right? So then that comes down in front of parentheses,
When did we ever learn this?
Well, I'm teaching it to my Accelerated 7 class, well, actually all my Math 7 classes right now. So you should have started learning factoring in 7th grade. So like if you had 9 minus 3x, you could say both of these can divide by 3, so then you could have 3 times 3 minus x, and that would be factoring that binomial.
Well, this is new.
Well, then make sure that you pay attention and focus on your practice tonight. So, what we're really doing inside the parentheses, especially because you just asked that I'm going to show a decent amount of the work. 5x then becomes the coefficient to everything. Inside the parentheses, you're now going to have 5x cubed divided by 5x plus 25x squared divided by 5x plus 45x divided by 5x. Each of these terms individually gets divided by 5x. That then will become what happens when we're dividing with exponents. We actually, Emily, subtract. So, Emily, for 5x cubed divided by 5x, what'd you get? Ooh, but the 5 divided by the 5.
X squared.
Yeah, it's just x squared. McKenna, what'd you get when you did 25x squared divided by 5x?
5x.
Yeah, just 5x. And then 45x divided by 5x, Kale? 9. Notice the index or the power of everything I started with has been reduced by 1. Because we divided by an index of 1, every index in my original expression will go down by 1. Questions on this? Grant, is this kind of making sense? Yeah?
Then do you do the multiplication after?
No, so, like, we are essentially working backwards. Hey, stop with the chatter. So when we factor, we essentially are undoing the distribution. So then we don't have to do anything else with this because we factored out the GCF. So then we're done. GCF of 3x to the 4th, 9x squared, 12x. Now here's some people go either way on this. If all of your terms are negative, then your GCF can be negative. If one of your terms is positive, we normally just use a positive greatest common factor. So Ben, do you know what would be the greatest common factor between these three values? 3x, right? My lowest index of power is x to the 1st. And then 3 is my lowest value. 9 is divisible by 3. 12 is divisible by 3. It'd be 3x. So then, just for the practice, this would become 3x times, well, 3x to the 4th divided by 3x. Raider, what would you get there?
Where are we?
So, do you want to do it, Ben?
Yeah, I was
Okay.
gonna do it.
Okay.
So,
Sorry, Raider. Hey, if you're going to do it, do it. Don't make me wait.
so it'd be x to the 3rd,
Yeah, x to the 3rd, the index drops by 1. The coefficients divide.
then minus 3x to the
Just
3x,
3x.
and then 4.
Yep, then just 4. Yeah. What?
Why in the one that we did before? Why did you put in parentheses like dividing it all by 5x?
To show what we did. To show how we found the values. Because, huh?
What did we do?
We divided. So we took the original value. So if you're looking up here on this board, I can't erase that. So we took this original value, 5x cubed, and still had, to get the new value in the parentheses, we had to take the 5x cubed and divide it by the 5x, which got the new x squared. Because we're pulling out a common value. Again, this is one of those situations where we're in the middle of learning it. It's still kind of like, what are we doing? Just hang on. Do you understand the process that we're doing? Because then 5x gets divided down here, but by the 25x squared, so 25 divided by 5 gives me the 5. X squared divided by x gives me just x. And then 45x and 5x do the same thing. 45 divided by 5 gives me 9. X divided by x disappears.
Then why are we multiplying it all by 4x?
We're not multiplying at all. We're showing that we could. I know, but we're not going to do the multiplication. We're just going to write it like that. Because if we did the multiplication, we'd get back to right where we started. Hang on. You're taking that very like high schooly attitude. Try it on your own. What's the factored form of this? So you want to pull out the greatest common factor from all of them, and then figure out what trinomial will be in the parentheses.
I got it.
That's not here. Wyatt, what'd you find? GCF?
4x.
GCF is 4x. Then I have
X to the 4th.
x to the 4th
Minus 6x squared.
minus 6x squared
Plus 2.
plus 2. Questions on how we did that?
The rest of us more or less
Yeah.
trying to figure that
Yeah,
out.
so you're dividing the 4x, right? So
Yeah.
back to GCF. Then why is it 6x squared? Is it,
So,
24 divided by 4.
yeah, but then if you're getting rid of the x too.
when we divide by 4x, we can either draw it like this, or we can draw it like this divides by 4x, this divides by 4x, and this divides by 4x. So we really do the coefficients, then the variables. So my 4 divided by 4 gives me 1, so I don't have to write it. X to the 5th divided by x, I subtract the powers, I get x to the 4th. Negative 24, because the sign has to go with it, divided by 4, gives me negative 6. X cubed divided by x,
Oh, x cubed.
x
I get
squared.
it.
Yeah, and then 8x divided by 4x just gives me 2. This one's a bit more tricky.
No, I had it before both of I had it
I
before
don't
both of you.
care.
Actually,
I'm using a deck of random cards. How childish are we?
Are you kidding me?
Mr. Carpenter, all I want from you is the greatest common factor.
Can I give you the rest of the problems?
Sure.
Okay.
You can also give Ben's face the palm if you need.
Oh, yeah.
I'd be happy to
Like-
do that.
Can I have a pen in my hand too when I do one?
No. Okay, Grant, greatest common factor.
9x squared.
Now, I would agree if
Well,
my other coefficients could divide by 9. So we look at our smallest coefficient, but, and this is where this one gets tricky.
3 to the 3rd.
Yeah, it's 3. Because 9 is my smallest coefficient, but that doesn't make it the GCF.
Okay.
I have to look at what are the factors of 9 that 15 and 12 can also divide by. So we get 3x squared
Okay. Wait, are we sharing squared or?
Wait, why
because
squared?
my lowest index is x squared, so I can use that in the GCF because again, we look at the lowest coefficient. Sometimes we have to break it up into its factors, and we can take the lowest index because I know x to the 6th, x to the 4th, and x squared will all divide by x squared.
Okay, from there it's 9x to the 6th over
Oh, you're gonna give me the whole thing. Okay, perfect. 9x to the 6th over
3x. Plus 15x to the 4th over 3x squared, and then 12x squared over 3x squared. You want me to do the rest?
Yeah, to have greatest common factor, you have to have x squared here. If you just use 3x, you can still factor out more, so you're not in the lowest factor form. So then, Grant, do you want to keep going?
Sure.
So,
3x squared.
3x what? Oh, sorry, you were giving me the first one.
Yeah, 3x to the 4th
Yep, x to the 4th plus
plus 5x
Yep.
plus 4x.
No x. X
No
squared
x.
divided by x squared cancel each other. They become 1.
Yep.
Questions on this? Did we actually write it down so we'll remember on our homework?
Yep.
Yeah.
Here is a why we do things like this. Helicopter landing pad is sometimes marked with a circle inside a square so it's visible from the air because you got to land in the circle. It's like the reinforced part of the roof, but the square will help you see it. What is the area of the shaded region of the helipad at the, well, it says at the right, but I moved things around. Write your answer in factored form. So, do we know anything about the circle to find its area? Greg, what do you think?
Radius.
Well, do we really know? I mean, kind of, yeah.
Yeah, half of 2x.
But if we want the area of the shaded region, how are we going to do that?
What's shaded?
So let's say we're on this roof. We're going to paint these red areas so they can see exactly where the helicopter should be. So we want to know how much paint are we going to need to do this?
I'm ready to.
Leah, any ideas? Of a you don't even have to tell me the math, just what process we could do to find.
You could find the area of like the square if it didn't have the circle and then subtract the area of the circle.
Yeah. So we want to do the square minus the circle, and of course we're talking area here. Timber, my one dog, had me up last night from 1:45 until after 3 a.m. I think he's sick. So,
I wrote the equation.
so area of the square, do you want to keep going or do you want me to move on?
Would it be 2x times 2x?
Yeah, so we could say 2x squared.
And then minus pi x
Yep.
squared.
Pi times x squared.
Putting the 1 in front of the x, is that like okay?
Yeah, it's not going to make a difference. You mean this x,
Well, yeah,
right?
I know it doesn't make a difference,
Yep.
but would that be like math?
Yep. But now we wouldn't need the 1 since we have pi. Now we wouldn't need it's pi x squared. So if you want to put a number there, it'd be like 3.14 approximately. This squared, be careful, goes to both the coefficient and the variable. So what do we get? 4x squared minus pi x squared. But now I can simplify this by factoring out whatever's common. Emily, your card is up. X squared is common to the both of them. So now I can just say, well, if I pull out the x squared, this really becomes x squared times, what do you get on the end? Yeah, sure. Yep, 4 minus pi.
Because you still keep it
Because it wants to
square.
answer on
They're not on like 4 and pi.
So then 4 minus pi would be approximately 0.85.
Yep.
A little bit over that. So we have about 0.85 x squared. So then, depending on the size of the helipad, will depend on what the area actually is. All we have to do is plug in the x. Questions?
Nope.
Quandaries, queries. There's a game called Quelf that's very fun.
I've played some.
I like disco golf.
I like disc golf, but I've never played
In this problem, you will
Disco balls.
Try the Goddard on your own. Hey, Greg, now it's your turn.
now it's your turn.
Try the Goddard on your own. Put down your hand, I don't care.
I got it.
Sorry, but all it's going to do is make your hand go numb.
That's a good thing.
It won't get you called out. I have cards.
Disco golf.
I just envision people disc golfing with like platform shoes and like an afro.
Oh no, it's way better. Instead of using golf balls, you use an actual disco ball.
No, I accidentally.
Yeah, I think your disco ball would get ruined very quickly. And mirror balls are very expensive actually.
Oh, like it's like titanium. It's a titanium ball.
So I think you probably break it. Well, titanium's light, but it's still a dense metal. Like it's very, very strong. Dense is the wrong word, but it's very, very strong. So you might end up breaking a golf club. Unless you use a baseball bat.
Or titanium ball.
A metal
Well, that you can probably find a titanium baseball bat. I guarantee there are some. Straveler.
Okay, so basically it's like the same process as the other one. So I got 36x squared minus parentheses 3x squared times 5, 3x squared. Wait, it's not simplified yet, gosh.
Yeah, that makes sense.
Okay, this.
You meant like quantity 3x
Right.
squared, right?
Right. So
Yeah.
then you get, if you want to simplify more, you get 36x squared minus.
Where did my 6 go? 36x squared minus 9x squared.
Okay, and then what you can do is you can simplify it down for the x common factor x squared.
Yep.
So then you get x squared times 36 minus 9, 5. But then since you know that 36 and 9 have a common factor of.
So when we look for our greatest, the x squared was not actually the greatest common factor. 9x squared is really your greatest common factor. I'm curious how many of you actually had the 9x squared factored out. So then again, it's 4 minus 5. So this helipad is just 9 times as large as the previous one. Area-wise. Jacob?
So I have something to say that, but we could take a different path. So this shape is similar to the previous one, which had a side length of 2x and x as the radius.
Yeah.
So we could put 3 outside of the previous equation of the that, and the 3 would be squared, so you just have 9, and you just have to multiply 9.
You can look at it as having a difference factor of 3, but since we're talking area, that difference of 3 would have to be squared to deal with the area. So that's another route that we could get to the 9.
Hoffman, no.
No, he's in math 1.
Anyone want to guess how many problems there are?